If you're creating a dialogue-heavy game, chances are you've looked into or are using the Ink scripting language. I won't go into all the benefits over other systems, but I will caution against dialogue graphs integrated into your engine. Your writers shouldn't need to open your engine to write the dialogue, and they shouldn't need to use their mouse to create each line of dialogue by creating nodes and attaching them together. But when using Ink, it can be difficult to connect your game logic to the story logic. I figured maybe I could use ScriptableObjects to connect the two. This is BGK of Pear Tree Games, and this is a recap of my attempts to extend the ScriptableObject Variable architecture to InkVariables. The basic principle of the base architecture is you have a scriptable object which stores a value. Usually, that value can be subscribed to be notified if it changes, which allows you to use a drag-and-drop style dependency injection, and that's about it. Now, if we want to be able to use an Ink variable or a stored variable, we have two options as I see it. One, we can just extend each of the individually typed objects, but then we'd have to duplicate all of our overrides individually. Or two, we have our scriptable objects store an interface, and we can swap it out with whatever implementation we want. Since I haven't used the serialized reference attribute much, I figured I'd give it a shot to see if it was possible to implement it the second way. Spoiler, it is, but my implementation isn't worth the hassle. Unity lists two caveats to using serialized reference that we'll need to keep note of. One, the field can't be of type UnityEngine.object, so plain old class objects it will be. And two, the field value cannot be a specific specialization of a generic type, which makes sense but really adds to the boilerplate for our use case. I'm going to start with a new project and create two folders we'll use to make the standard variable and InkVariable modules into packages. Then I'll fill out the fields in accordance with the package spec and add our runtime and editor folders. And now we'll add the local packages to our project using the package manager along with the Ink Unity integration. As always, we'll start our code by making our assembly definition files. We're going to separate our interfaces into two categories: an event interface with a generic version, and a variable interface which will inherit the event interface. Now, we'll create classes which will implement each of those interfaces. With all of that complete, we can create a scriptable object which will serialize the reference to an event variable interface. Let's take a moment to dissect that class declaration. Ideally, what we'd want is to simply have a generic class take in an event variable generic type. However, since we need to have a concrete interface and can't serialize generics, we'll pass that in as t, but constrain it to the event variable of type tu, which is our base underlying type we're trying to store. And we'll pass in a default type to instantiate so we don't have to create a selector for every inherited type. So we'll need to constrain that with new, or as a public parameterless constructor. We'll create our first variable object as an integer. We'll need to create concrete versions of our interface and a default class which implements that interface. However, the default class is never being instantiated because we're never using the variable getter. Let's try a custom inspector to display that. We could also use the onValidate lifecycle method for this instead. The inspector just casts the target to the event variable object, and then we'll use the getter to get the variable, which will instantiate it if it doesn't exist, and then we'll display it as a label. Following that, we'll just display the regular property as normal. And this is where I forgot that custom inspectors also can't be generic, so we'll have to do concrete types for each one. I'm going to create the rest of our base variable type objects. By this point, I realize I don't like this implementation at all, but figured I'd create the InkVariables and see how it goes. Our InkVariables will need access to the ink story and the variable name that we're looking for. Then we'll map our values and subscribers to the ink story variables and observers. To subscribe to an ink variable, we'll need to create a variable observer. We'll also need to keep track of those observers so that we can unobserve them when we want to unsubscribe. Now we can create our base InkVariable types. To pass our story into our variables, we're actually going to use the ScriptableObject variable and create a story object. To create the InkVariable objects, we're going to create a scriptable object to parse an Ink file, then instantiate and store those variables as sub-assets. We'll delete any existing sub-assets to make sure we always have the most up-to-date data. Then we'll compile the Ink file so we can get all the variables inside. My own convention is to start the variable names with the type and then an underscore. So I'm going to use that to simply switch over all of the variables so I can decide which one to use, but there's plenty of other ways you could do this. Once we know the type, we can set the object variable to the Ink variable. And now we can add the newly created object as a sub-object of our current collection. To connect our variable objects up, we're going to create a mono behavior that will load up all of the collection variables and then pass in the story object. For testing, we'll have the variable loader also just initialize the ink story, but normally you'd have an ink runner of some sort to actually run the story. And there we go. Although I'm not happy with the code, so I think in part 2 I will just show you that I ripped it all down and went with the first method of simply extending each of the individual objects. Now, originally I didn't want to do that because there would be a lot of duplication of code, but in the end it reduces the boilerplate, and there's so few actual reasons that you'd want to switch out the variable object that the scriptable object is holding, that this just doesn't make sense. So part 2 will be there if you'd like to watch that, but I'm not going to be really explaining anything. I'll just keep the video, just post the video as is. So if you're interested in that, go ahead. Thank you very much for watching.